the area of this shaded region, the first step we are going to do is to get the angle subtended at the center of these two circles. And for you to get that, first of all, we can draw a line from the center of circle 1 to center of circle 2. This line is going to divide AB into two equal halves. It will be a bisector, which means that we are going to get a small triangle here. Let's say these 2 points are going to meet here, M. We're going to get a small triangle O1AM, whereby AM will be 4 centimeter and OA1 is 6 centimeter. So to get using this triangle, which is a right angle triangle, we can be able to find this small angle here, and we use sine theta. Let's call that angle theta is equals to the opposite side of the angle, which is 4, divided by the hypotenuse side of the triangle, which is 6. And to get the angle itself, we're going to find sine inverse of 4 over 6, whereby theta will be using a calculator. The value of theta will be 41.81. Remember, the angle subtended at the center is not 41.81. The angle subtended at the center is angle A or 1B, which is twice of theta, 41.81. That gives us 83.62 degrees. So to get the angle subtended at the center of circle 2, we are going to use triangle A or 2M, where AM is still 4 centimeter and the radius of the circle 2, which is 5 centimeter, is the length of AO2. Again, we need to get this small angle. We use sine. Let's call theta. So the angle is sine theta equals to the opposite side to the angle, which is 5, divided by the hypotenuse side of the triangle, which is 5. The opposite side is 4 divided by 5. Then to get theta, we find sine inverse of 4 divided by 5. Theta will be, using a calculator, 53.13 degrees. But then the angle we want is the angle subtended at the center, which is angle AO2B, and that is twice of 53.13, which gives us 106.2. Now, to get the area of the shaded region, you need to know that it comprises of the area of two segments. Circle 1, segment of circle 1, and segment of circle 2. So if we start with the area of segment 1, we are going to use circle 1, the sector of circle 1, which is given by this A or 1B, where this angle is already 83.62 degrees. We calculated before. To get the shaded part, which is this part, now is the area of the whole figure, that is the sector, minus the area of the triangular part, because we know that this is 6 centimeter both, since it is the radius of the circle. So how do we get the area of this figure? This figure is now called a sector. So the whole figure is the area of a sector. Sector is theta over 360 times pi r squared. Then we subtract the unshaded part, which is a triangle, the area of the triangle, using a half AB sine theta. So we know theta, that is 83.62. So we shall have theta 83.62 divided by 360 times 22 over 7, that is pi, and then times the radius, 6 squared, minus a half times 6 times 6, then multiply the sine of the angle subtended at the center, which is 83.62. Using a calculator, what we get from this one is 26.28 minus 17.89, and that gives us 8.39 centimeters squared as the area of the shaded part 1, which we call the area of segment 1. Then we can proceed to the area of segment 2. Area of segment 2 and here we need to use circle 2. The sector of circle 2, as you can see, it's from here to there to there. I mean, if I draw, it will be like this, which is this shaded part in circle 1. And here we will have A, B, the common chord, and here is the center of circle 2. So we know the length of these two sides of a triangle, that is the radius of circle 2. So this angle is the angle subtended at the center of circle 2, which is 106.26. Now using this formula, theta over 360, our theta will be 106.26 divided by 360 times pi is 22/7 times the radius squared, which is 5, then minus a half times AB will be 5 times 5, then multiply the sine of 106.26 degrees. The result from here is 23.19 minus approximately 12. This will give us 11.19 centimeters squared. So we've got the area of segment 2, which is half of the shaded part, and half of the shaded part we already calculated. It is 8.39. So the area of shaded region is given by the area of segment 1, 8.39, plus the area of segment 2, which is 11.19, and this gives us 19.58 centimeter squared.